Hello, welcome back. We have a new day. It's Wednesday, but I have recorded a lot of video today. The weather is nice. Why I have this cable so far out my table, no, my floor. I have to fix it later. So let's read about this old Boeing airliner. Try to read about this. Actually, that's not so. Actually, we could do it one video. Could finish this in one part video. So let's get started.
Boeing 367 to 80. From Wikipedia, the free encyclopedia. Boeing 367-80. Boeing 367 to 80 in flight.jpg. The Dash 80 is a low-wing, quad-jet aircraft roller prototype transport /airliner manufacturing first flight July 15, 1954 introduction 1955 retired 1970 status preserved produced 1954 number built 1 developed into Boeing C-135 Straight lifter Boeing KC-135 Straight Otenka Boeing 707 other name S-80 registration N70700 owners and operators engine service 1954-1969 preserved at National Air and Space Museum S. Stephen F. Advarhazy Eye Center. The Boeing 367-80, known simply as the Dash 80, is an American quad-jet prototype aircraft built by Boeing to demonstrate the advantages of jet propulsion for commercial aviation. It served as basis for the design of KC-135 tanker and the 707 airliner. The Dash 80 first flew in 1954, less than 2 years from project launch. Its $16 million cost, equivalent to $161 million today, was an enormous risk for Boeing, which at the time had no committed customers. Only one example was built, which has been preserved and is currently on public display at the Smithsonian's National Air and Space Museum's Advarhazy Center in Virginia. Design and development. By the late 1940s, 2 developments encouraged Boeing to begin considering building a passenger jet. The first was the maiden flight in 1947 of Boeing's B-47 Stratojet bomber. The second was the maiden flight in 1949 of the world's first jet airliner, the de Havilland Comet. Boeing President Bill Allen led a company delegation to the UK in summer 1950, where they saw the Comet fly at the Farnborough Air Show, and also visited the de Havilland factory at Hatfield, Hertfordshire, where the Comets were being built. Boeing felt it had mastered the swept wing and podded engines, which it saw as key technologies that will enable it to improve on the Comet. The Boeing 367-80 during its rollout in May 1954. In 1950, Boeing tentatively produced a specification for a jet airliner dubbed the Model 473-60C. 1. The airlines were unconvinced. 2. Because they had no experience with jet transports and were enjoying success with piston-engined aircraft such as the Douglas DC-4, DC-6, Boeing Stratocruiser and Lockheed Constellation. Boeing was experienced at selling to the military but had not enjoyed the same success with civil airliners. This market was dominated by Douglas, which was adept at meeting the needs of airlines by refining and developing its range of propeller-driven aircraft, and in 1950 was marketing the forthcoming DC-7. Boeing decided the only way to overcome the airline's suspicion of the jet and of itself was to show them a completed aircraft. 3. The Boeing 367-80 at Boeing Field in Washington, 2000, as the first of a new generation of passenger jets. Boeing wanted aircraft's model number to emphasize the difference from its previous propeller-driven aircraft, which bore 300 series numbers. The 400, 500, and 600 series were already used by missiles and other products, so Boeing decided that the jets would bear 700 series numbers, and the first would be the 707.4. The marketing department at Boeing chose 707 because they thought it was more appealing than 700.5. Boeing had studied developments of its existing Model 367, the KC-97 straight-off freighter, incorporating swept wings and podded engines, and chose to build the 367-80, which retained little of the KC-97 except the upper fuselage diameter, and the possibility of building some of the fuselage with existing tooling. Although the design was announced publicly as the Model 707, the prototype was referred to within Boeing simply as the -80 or 80. The -80 fuselage was wide enough at 132 inches, 335 centimeters, for 5 abreast seating, 2 on one side of aisle and 3 on the other. The fuselage diameter for the production KC-135 was widened to 144 inches, 366 centimeters, and Boeing originally hoped to build the 707 fuselage with that width. By the time the Boeing company committed to production, the decision had been made to design the production Model 707 as a 6 abreast design, with a larger 148-inch diameter, 376 centimeters, fuselage, after C.R. Smith, CEO of American Airlines, told Boeing he wouldn't buy the 707 unless it was an inch wider than the then proposed Douglas DC-8 passenger jet. This decision did not unduly delay the introduction of the production model, since the -80 had been largely hand-built, using little production tooling. 6. Tex Johnston noted, months before the Comet's tragic vulnerability became known, Boeing engineers specified aluminum skin of a significantly thicker gauge. In addition, they welded titanium tear stoppers at frequent intervals inside the skin, including plug-type doors that sealed tighter as the cabin pressure differential increased at higher altitudes, switched to triple-strength round-corner windows, and used spot welds, instead of rivets, and a 20-inch circumferential rib spacing. Boeing subjected a -80, 707, fuselage of that design to thousands of pressurization cycles, proving the validity of the structure. 7. Operational history. By early 1952 the designs were complete, and in April the Boeing board approved the program. Construction of the -80 started in November in a walled-off section of Boeing's Renton plant. 8. As a proof of concept prototype, there was no certification and no production line, and most of the parts were custom built. The aircraft was not fitted with an airline cabin. A plywood lining housed the instrumentation for the flight test program. Boeing 367-80, N70700, prototype in a NASA archive photo. The -80 rolled out of the factory on the 15th of May, 1954, 2 years after the project was approved and 18 months after construction had started. 9. During a series of taxi trials, the port landing gear collapsed on the 22nd of May. The damage was quickly repaired and the first flight was on the 15th of July, 1954. Following flights revealed a propensity to Dutch roll, an alternating yawing and rolling motion. Boeing already had experience with this on the B-47 Stratojet and B-52 Stratofortress, and had developed a yaw damper system on the B-47 that could be adapted to the -80. Other problems were found with the engines and brakes, the latter once failing completely on landing, causing the aircraft to overshoot the runway. 10. Boeing used the -80 on demonstration flights for airline executives and other industry figures. These focused attention on the question of what the cabin of a passenger jet should look like. In a departure from its usual practice, Boeing hired industrial design firm Walter Darwin Teague to create a cabin. Prior to demonstration for passenger airlines, the Dash 80 was fitted with Boeing's flying boom for aerial refueling, which served as a prototype for the KC-135 Stratotanker and its later derivatives. The barrel roll. As part of the Dash 80's demonstration program, Bill Allen invited representatives of the Aircraft Industries Association, AIA, and International Air Transport Association, IATA, to the Seattle's 1955 Seafair and Gold Cup hydroplane races held on Lake Washington on the 6th of August, 1955. The Dash 80 was scheduled to perform a simple flyover, but Boeing test pilot Alvin Tex Johnston instead performed 2 barrel rolls to show off the jet airliner. 11. The next day, Allen summoned Johnston to his office and told him not to perform such a maneuver again, to which Johnston replied that he was simply selling airplanes and asserted that doing so was completely safe. 12. N1. Boeing Chief Test Pilot John Cashman stated that just before he piloted the maiden flight of the Boeing 777 on the 12th of June, 1994, his last instructions from then Boeing President Phil Condit were no rolls. 13. Use as an experimental aircraft. After the arrival of the first production 707 in 1957, the Dash 80 was adapted into a general experimental aircraft and used by Boeing to test a variety of new technologies and systems. One of its most important tasks during the late 1950s was to test systems for the new Boeing 727, including the fitting of a fifth engine in the rear fuselage. 2. Other tests included experiments with different airfoil shapes and a number of high-lift devices such as blown flaps, in which compressed air bled from the engines is directed over the flaps to increase lift during takeoff and landing. Final flight. After 2,350 hours and 1,691 flights, the aircraft was withdrawn from use in 1969 and placed in storage. 14. On the 26th of May, 1972, Boeing donated the 367-80 to the Smithsonian Air and Space Museum, which had designated it one of the 12 most significant aircraft of all time. 14. For the next 18 years the aircraft was stored at a desert boneyard now called the 309th Aerospace Maintenance and Regeneration Group. Boeing 367-80 at the National Air and Space Museum's Stephen F. Udvar-Hazy Center, 2009, AMOG, at Davis Monthan Air Force Base near Tucson, Arizona, before being retrieved by Boeing in 1990 for restoration. The Dash 80's final flight was to Dulles International Airport near Washington, D.C. on the 27th of August, 2003. Repainted to its original yellow and brown Boeing livery, it was put on display at the Stephen F. Udvar-Hazy Center, an annex of the Smithsonian Institution's National Air and Space Museum, located adjacent to Dulles Airport in Chantilly, Virginia. 15. Specifications. Boeing 367-80. Data from Boeing aircraft since 1916. 16. General characteristics. Crew, 3. Length, 127 feet 10 in, 38.96 m. Wingspan, 129 feet 8 in, 39.52 m. Height, 38 feet 0 in, 11.58 m. Wing area, 2,400 square feet, 220 square meters. Empty weight, 92,120 pound, 41,785 kilograms. Gross weight, 190,000 pound, 86,183 kilograms. Power plant, 4 Pratt & Whitney JT3 turbojets, 10,000 lbf, 44 kN, thrust each. Performance maximum speed, 582 miles per hour, 937 kilometers per hour, 506 kn, at 25,000 feet, 7,600 m. Cruise speed, 550 miles per hour, 890 kilometers per hour, 480 kn. Range, 3,530 mi, 5,680 kilometers, 3,017 mi. Service ceiling, 43,000 feet, 13,000 m. Rate of climb, 2,500 foot /min, 13 m /s. See also. Aviation portal related development Boeing RC-135. Boeing KC-135 Stratotanker. Boeing C-135 Stratolifter. Boeing C-137 Stratoliner. Boeing 707. Boeing 720. Boeing 727. Boeing 737. Aircraft of comparable role, configuration, and era. Convair 880. Douglas DC-8. De Havilland Comet. References. Notes the contention that the maneuver was dangerous was refuted by John.
Good. So I will take a break and upload. I think I will cycle to the Lidl discount supermarket. So I will take a break and upload. I will look which aircraft I'm reading next. Probably Boeing 707.